with section 3 of chapter 9. Okay, we are going to talk about reactions in aqueous solutions. Objectives: describe aqueous solutions. Write a complete ionic and net ionic equation for chemical reactions in aqueous solutions. Predict whether reactions in aqueous solutions will produce a precipitate, a water, or a gas. Remember that a solution is a uniform mixture that might contain a solid, liquid, or a gas. New vocabulary: aqueous solution, solute, solvent, complete ionic equation, spectator ion, net ionic equation. Main idea: double replacement reactions occur between substances in aqueous solutions and produce precipitates, water, or gas. Okay, an aqueous solution contains one or more dissolved substances called solutes in water. A solvent is the most plentiful solvent in a solution. It is the one that breaks down the other substance, such as the solid. So if you have if you have salt and water, the salt is the solid, that is the solute. The water is the solvent, breaks it down. Water is always the solvent in an aqueous solution. There are many possible solutes. Sugar and alcohol are molecular compounds that exist as molecules in aqueous solutions. Compounds that produce hydrogen ions in aqueous solutions are called acids, and we have talked just a little bit about how to name and write an acid formula. Ionic compounds can also be solutes in aqueous solution. When ionic compounds dissolve in water, their ions separate in a process called dissociation. That means to break apart. Okay, when two solutions that contain ions as solutes are combined, the ions might react. So remember, an ion is a charged particle, positive and negative. An ionic compound that I think of right off the top of my head is sodium chloride. Remember, the sodium was the positive, the cation, and the chlorine was the negative, the anion. If they react, it's always a double replacement reaction. Three products that can form. You guys are really good at giving me this answer: precipitate, water, or gas. Okay, so let's look at this one. We have aqueous solution of sodium hydroxide and copper 2 chloride react to form a precipitate of copper hydroxide. Now you can see that they have the balanced equation down here. They call that a balanced molecular equation. Notice in the product they don't say, they say that it produces the precipitate of calcium hydroxide. But you know, since it's a double replacement reaction, that you are also going to have sodium chloride. And right here is where it really comes into play that you need to say, make sure you have the aqueous, the solid, or the liquid behind it. Solid, especially for these double replacement reactions, means the precipitate. Ionic equations show all of the particles in a solution as they actually exist. That is called a complete ionic equation. And here is your equation that is now broken down. You have two sodiums that are plus, you have two hydroxides that are minus. You have a copper, which is a +2, still aqueous, and you have two chlorines that are negative. On the product side, you have two sodiums that are positive, you have two chlorines that are negative. Now the solids never come apart. They always stay together. Ions that do not participate in a reaction are called spectator ions, and they are not usually written in the equation. They are there just to kind of hang out. They really don't participate. Formulas that include only the particles that participate in the reaction are called net ionic equations, and that's where we're trying to get to. So if you go back to the previous equation, okay, you cross out all the spectator ions. You can see that you have two sodiums on this side and two sodiums on the product side. You have two chlorines on the reactant side, two chlorines on the product side. So you cancel those out, and what you're left with is your net ionic equation. 2OH plus Cu2 yields CuOH. Okay? All right. Some reactions produce more water molecules. No evidence of a chemical reaction is observed. Okay, so remember we talked about water being in the product side. Okay, if you take out the spectator ions, okay, this is what you'll end up with. Remember, they skipped a step. They did not write out the complete ionic equation here. They have just taken out the spectator ions. Okay, gases are commonly produced. The gases that are commonly produced are carbon dioxide, hydrogen cyanide, and hydrogen sulfide. And this one is an example of hydrogen cyanide. Another example is when you mix vinegar and baking soda, and that's going to produce your CO2. Okay, but you can see that sodium bicarbonate is going to decompose right away. Okay, so this is what is left. This is your equation that you're left with. Okay, two reactions can be combined and represented by a single chemical reaction. So here we have a double displacement reaction. You have hydrochloric acid and your reactant. And then you go to your product. Now, you can take this down. You can see that this one right here, this hydrogen carbonate, is going to have its own decomposition reaction within this double displacement reaction. That's what they're talking about with the two reactions being combined. Okay, and here they have broken it down for you. Now if we would put them together, this is what you would get. And then if you take out the spectator ions, this is your overall equation. Now, I went through that really fast, and I did that for a reason, because this is a really super good YouTube video that I want you to go watch. This lady does an awesome job of explaining this stuff. She goes through 3 separate examples of how to do these. Please watch that, because in class we're going to be doing more of the complete ionic and the net ionic equations.